Okay, we are going to look at question 5 now, guys. So question 5 is, again, another functions question, but this time we're looking at an exponential graph. Okay, the reason we can tell it's exponential is because they've given us the form of an exponential where we have x in the exponent, right? They haven't given us k, but they've told us that k is greater than 0, and they've given us a point on the graph, right, to help us. But look, there's another point, right? So there's 2 points they've given us, and let's now jump into the questions. So it says determine the value of k. Okay, so k is the base value of x in the exponential graph. Okay, so let's just write that down. So we have f of x, okay, with f of x is equal to kx. Okay, and we know that k is greater than 0. But what we're going to have to do here, right, and I'm just going to write this in the form of y, so f of x is now just going to equal y, okay? We do have 2 points in the graph, so we have 4 and 16, and we have 0 and 1, okay? Because that's the y-intercept, and this is another point they've given us. So what we can do, okay, is we can just substitute, right? We can just substitute one of these points into this graph. I would be inclined to use this one because often when you work with zeros, it's not too useful in finding x values, right? I mean, in finding unknowns, because the x value here is 0. So let me just show you, right? If we want to say 1 equals k to the 0, right? Then how would you find out k? Because anything to the power of 0 equals 1. Okay, so that's not too useful to use that point. Let's rather use 4 and 16. So I'm going to say 16 equals k to the 4. Okay, so what we're going to have to do now is get rid of that power of 4. So we're going to do root 4. What we do to the one side, we must always do to the other side. So we get k by itself. And then I'm going to put the 4th root of 16 into my calculator, which is 2. Okay. Now I'm going to write plus minus 2, and you might be thinking, but Margs, like it said 2 on the calculator. But what's important is when we have a power, as you see over here, that is even. So I'm going to say yeah, even power, right? You always have to write plus minus, right, in front of the roots, because that indicates that you understand that if I say a positive times a positive, I get a positive. If I get a negative times a negative, it's also a positive. So you indicate that you understand this rule. And this rule repeats itself for every even power, okay? It is not the case for uneven, right, or odd. So if I say odd powers, right, if I have plus times plus times plus, it gives me a plus. But if I say negative times negative times negative, it gives me negative. So that rule doesn't hold for odd powers, but it does for even powers. But now we know they've given us, right? And that's why I wrote it here, that k has to be greater than 0. So we know that the k actually does have to equal 2, okay? So you could be thinking, oh, Margs, you did all that work for nothing. But this demonstrates understanding, okay? And also, if they hadn't given us that, then we would have to display the 2 roots, okay? That's important. So let's now move on to the second question. So 5.2 says graph G is obtained by reflecting f about the y equals x line. Determine the equation of G in the form y equals ... Okay, so we know that f of x equals 2 to the power of x. We just worked that out. So now we want to work out G of x. Okay, but G of x has to be reflected about the, I say x equals y, y equals x, same thing, okay? So this here is saying y equals 2x. So the reflection, right, the reflection of this in this line, in this x equals y or y equals x, right, we have to swap the x and the y value. So it's going to read like this, okay? But that is not our final answer. We have to read the question very particularly, right? So it says determine the equation of G in the form y. So they've basically said to us, right? And I often like to compare this to English. They've said, okay, the sentence is not wrong. This mathematical sentence or equation is not wrong. But we want you to write it so that y is the subject. I think about it as a bit like active and passive voice in English, okay? So what they're saying is, no, I want you to make y the subject. So what do we do, right, when we have a variable in the exponent? We have to look to our good old friend log, okay? If you're not familiar with log, guys, please go and revise it. There's a lot of rules around log which are really useful, right, and can be assessed. But here you cannot get to y as the subject, right, of the equation if you do not use log, okay? So I'm using a log rule here, right? When I log something with an exponent, the exponent can come to the front of the log, and then this is log x, because what you do to the one side, you must always do to the other, okay? So often at school, the base here is 10. I'm not too phased about it because it will give you the same answer regardless, right? So y equals log x over log 2, which can be written like this. Okay, if you are a bit confused about some of the rules that I'm using here, please, again, go look at your log rules, okay? There's a number of them, but it's important because it helps us here. It's also quite useful in finance. Okay, let's now go on to 5.3. So 5.3 says, let me just show you what I'm reading. So it says, sketch the graph G. Indicate on your graph the coordinates of 2 points of G. On G. So what's important here, before you do any sketching, right, I want us to look at the points we have on f of x. We have 4 and 16, and we have 0 and 1. But we know that g of x, right, all that happens with g of x is we've swapped our x and y's. So we know that this just becomes 16 and 4 as a point, and 1 and 0. So this is very important because what we do now is we've actually got 2 points to help us sketch the graph. Okay, and we can't sketch graph without points, right? That is like a fundamental. You either need the equation of the graph or you need points in order to connect the different parts of the graph together. Okay, so this is x and y. I generally would do this in pencil and not pen, but your girl Margie has just got to play a fire up in here. So the 1 point here is 1 and 0. And over here is, that's not, so I have to go up like this, and this is 16 and 4. So mine is definitely not drawn to scale, but you get the general idea. Okay, let's try go through the points. That's not a very good drawing, but that's neither here nor there. Okay, so that is my g of x graph, okay, which is a reflection of the exponential graph I had in the y equals x line, okay. So again, start with the points before you do any sketching. Okay, so that is that question done. Hope you can see. Yep. Let's now go on to 5.4. We are smashing this question. Okay, 5.4. So 5.4 says, hold a second. It says, let me show you what it says. It says, use your graph to determine the values of x, right? For which f of x times g of x is greater than 0. Okay, so now these questions are generally included in function questions because they're testing whether you understand relationships between different functions, okay? So they've asked us for the values of x, which is, I've written here, about the domain, okay? They're talking about the values of y, they're talking about the range. So let's look exactly how we can do this, okay? So I'm just going to draw a little sketch in here of our g of x, right, just so that we can see them in relation to each other, because that's quite important when it comes to this, because often with these sort of questions we just want to jump into the maths, right, but there is an element of just pure logic at looking at this visually, right? So what this is saying when I times this graph, when I multiply this graph by this graph, where is it going to be greater than 0? So where is it going to be positive, right? So we know, right, let me just get a nice little highlighter. We know, right, that over here, right, it is going to be negative, okay? And we know that it is positive in terms of our y value, right? Which is what we're interested in, because technically, right, these are both y values, right? These are in terms of y. So we're interested in our y. So remember, positive y is here, negative y is there. So we don't want to include anything below there, okay? Because that is going to give us a negative answer, and we want strictly positive, okay? And we know that the point here is going to be 1 and 0. So we can't do any point below 1 on the x-axis, right? Because then it's going to be a positive times negative, which gives us negative. And that does not fulfill our condition. But anything this side of 1, right, will be a positive times a positive, which gives us a positive. Okay. So it's a little bit, it's not necessarily like let's manipulate and get an answer. It's a little bit of logic. Okay. So here I'm going to say, well, x has to be greater. X has to be greater. And you can't say equal to, right? It has to be strictly greater than 1. Okay. So you can write it like that. Or say x is an element of 1 and positive infinity, right? Either of those are correct. The reason it doesn't include 1 is because at 1, right, our g of x equals 0. And our condition here has said that it must be strictly greater than 0. Can't equal 0, has to be bigger. Okay, so that would be our interval where that works for us. Okay, so also just remember to label things correctly. I'm labeling like a nana here. Oh, I'm just like making up my own oh goodness me, I am not doing a good job here. That is 1 and this is 2. I'm just making up my own numbering system here. Okay. Then we have g of x is less than negative 1. Okay. So let us see. Okay. Here I think we should maybe go into the formula of g of x, but let's see. Right. So this is basically saying where y is less than negative 1. So we know negative 1 is going to lie somewhere over here for y, right? That's going to be negative 1. So let's go back to our equation of g of x, which we had over here. So it's going to be y equals log 2x, okay? And we want that to equal, it has to be greater, right, than negative 1. So let's just see what it equals at negative 1, okay? So now we have log 2x. Okay, so now what we want to do is we want to undo our log, okay? So we want to say negative 1. We're going to have log x over log 2. Okay, you can write it like that. Then effectively we have negative log 2 equals log x. Okay, right? Is that correct? Because that would come up. Yeah, it would. Okay, when we have a negative log, right, that actually means this, right? That's what that means. Okay, so what we have, right, is with this negative, again, if you're not following what I'm saying, you need to go revise your log rules. This negative, right, basically means that this is actually represented as a half because, let me show you. So if I had 2 to the negative 1 and I logged it, right, what did I say to you before? You can bring the exponent forward. So it becomes like this. So I'm just reverting it back to this form because we're solving for x. So now my logs will drop and x will equal a half. Okay, so now we know that over here x equals a half. So we have here half and negative 1. So now it says where is it, and this is important, less than or equal to negative 1. Okay, less than or equal to negative 1. Okay, so let us see, right? So we know that it's going to be this area here. But what's important, right, is this is an asymptote, right? Same way that there's an asymptote for the exponential, there has to be an asymptote here for the log, right? Because look, let me show you. If we plug 0 into here, so if we say y equals log to 0, let me show you. We'll show you an error. Log, let's just make sure that base is correct, sorry. So we're going to say 2, 0. And look, I get a math error, right? So it means that it's an asymptote. So, right, x, this g of x is only less than negative 1 between 0 and a half on the x-axis, right? So it's between here, okay, 0 and a half. Okay, so it's important that you don't say it is negative infinity to a half because it doesn't go into any negative values on the x-axis. It goes from 0 onwards. So x would have to be an element of 0, right, including a half. The reason it doesn't include 0 is because at 0, that's where the asymptote is, right? It doesn't touch 0. It never equals 0. So you can't put a hard bracket because it's not inclusive. But here we're including half because, look, our sentence that we had to, our condition that we had to apply or we had to comply with, right, said that it could equal. It said this, right? It just has to be less than or equal to. And we know when it's equal to, it's a half. Okay, so that is our answer there. I know that it seems like a lot of work for this question, but I did more than what was strictly necessary to make sure that you understand. Okay, so now we are going on to our last question of this question. Okay, so it says, if h of x equals f negative x, calculate the value of x for which f of x minus hx equals 15 over 4. Okay, so this is a bit of like it was almost like a mathematical tongue twister. Okay, so we know that h of x equals negative, not negative. You see, I'm even making up my own sum here. I do that all the time. Okay, cool. But what we want to solve is f of x minus h of x equals 15 over 4. So we're going to say f of x minus f negative x. So I'm basically substituting based on this equals 15 over 4. So here we know that this equals 2 to the x because we worked that out already. And all we have to do here, it's the same function. It's just if there's an x, we put a negative, right? And that equals 15 over 4. So now we have to solve this, right? So this is the same as saying this. Okay, so that's what we have to do. So let's see what we can do. So let's maybe, let's see what we can do. So let's say, let's times through by this 2x. Let's get rid of that denominator and let's get rid of 4 as well. Okay, let's do that, but let's just do this one first. Okay, so this is going to be 2x minus 1 equals 15 over 4 times 2 to the power of x. Let me just move that down so that you can see. Okay, so let's now times through by 4. So it's going to be 4 times 2x minus 4, 15 times 2x. Okie dokes. Ooh, and look, I just dropped an exponent there. Okay, but now look what we can do. I'm going to use the K method, right? Because this is just a squared version of this. Okay, so let me just show you what I'm going to do. I'm going to say 2x equals K. I'm going to say let 2x. So then we get 4k squared minus 4. I'm going to bring that this side, minus 15k. Okay, I'm going to write that in a more sort of traditional way so that you are comfortable. Look, it's just a quadratic, right? Easy peasy quadratic. Okay, so what you can do if you dislike factorizing in this form, I'm not a big fan myself, but you can put it into the quadratic formula if you want to and plug it into your calculator, or we can just try figure it out. Remember, we are factorizing it. We're trying to figure out where it equals 0. Okay, so generally do stuff like I'm just assuming and we'll test whether it's right or not. Okay, then it's going to be, let me just check, I think plus 1 minus, is it minus? Let me think. Plus 1, I think it would be minus 4. Let's just double check. Okay, so that would be 4k squared. That would be negative 16k plus k. That would get to 15, negative 4. Okay, so we've done our factorization. We know that 4k plus 1 equals 0. Or k equals, so k minus 4 equals 0. I'm jumping ahead here. So k equals negative 1 over 4. Or k equals 4. Okay. Now, it's important, right, that we have to now sub it back so that we can find out what x equals, right? We need to find what the x value would equal in order for this condition to be met. Okie dokes. So let's do it. Okay, so now we have 2 to the power of x equals negative 1 over 4, and we have 2 to the x equals 4. So this one's fairly easy on this side, right? Because we can just get the same base, then we know that x equals 2. So that's fairly easy. But this one is a little bit trickier because this, right, how do we get something, right, if we have 2 to the power of x, right, and we want it to equal something negative, right? And that's not going to work. It's impossible. We can't get it to equal something negative, right? Because we would then, there's just no way of doing it, right? It's just not applicable. Like mathematically, we can't find a solution there, right? So the only solution is x equals 2, right? Because this cannot be solved, right? Because 2 to the power of something, right, is never going to give us something negative. Okay, it will always give us something positive, and yet here it wants us to give us something negative. So it can't happen. Okay, so the value here is x equals 2. Okay, that question was quite lengthy and quite complex, but it was a very good question to practice. It involved functions, it involved reflections, it involved understanding domains and log rules. Okay, I hope that was helpful. Let's move on to question 6.